Okay, this is the last subsection of Chapter 12 and this is about second order differential equations. And basically, if I've got a second order differential equation, it looks something like this, where it looks like a second derivative. And the key concept that we're going to be using in this chapter is we're going to be substituting y in place of dx dt. And then hence the x squared dt we're going to be replacing with dy dt. Okay, and so we'll go over an example with that in just a minute. This part is explained in great detail by IB Vodcasting, so I'm not going to explain this at all because I want you to hear his explanation. You can hit pause if you want to copy my work because his handwriting is not so good. Okay, and then he talks about how because of the A value being positive, we have an unstable spiral from the eigenvalues. Okay, so the next part is not IB vodcasting. I'm going to go over it with you. Okay, so we've got this second order differential equation, and given that when t is 0, the price of whatever this thing is $10, and the rate of change is $1. Okay, so rate of change means derivative, right? So this is dy dt, dx dt. That means rate of change is going to be 1, and we're going to use that down here. Here, my initial price when t equals 0 has a price where x is 10, and then the rate of change is going to be 1. This is the same thing as y is going to equal to 1. So we're going to use this information for my initial values for calculation that we write in these spots here. But let's first change this into a coupled differential equation. So as I mentioned earlier, on the first from the IB vodcasting, we're going to let y equal d. Well, I guess it's d p dt. Okay, and so using that substitution right there and right here, I'm going to end up with dy dt, replacing that with that, plus 5y plus 18p equals 117. Okay, so now I'm going to rearrange this and solving for dy dt. And so since we want to isolate this, I can subtract 5y on both sides, so equals negative 5y. We can subtract 18p on both sides, so minus 18p, and then we still have the 117 on this side. Okay, and then the other equation is just simply this, so dp dt equals y. Okay, and so there is my coupled differential equations. When you go off to college, people are going to say, "Oh, diffie-q's, do-do-do." So whenever you hear somebody say diffie-q's, they mean differential equations. Okay, so This is the first step to write our coupled differential equations. Okay, so now I need to write my um, formulas that I'm going to be putting into my calculator, and using Euler's method, which you can get from your formula packet. Our step size is 0.1, so we can say y subscript n is equal to y subscript n minus 1 plus 0.1 times that. Let's get a better green marker than that one. Okay, times that, which is equal to, I'm going to write actually this guy here. I'm going to let p equals x. Okay, if I'm going to let p equals x, then I'm going to have my xn equal xn minus 1 plus 0.1 times this, which is y subscript n minus 1. Okay, and now I'm going to write this. So minus 5 y subscript n minus 1 minus 18 x subscript n minus 1 plus 117. Okay. Okay, good. And then final portion of what we're going to do here, t subscript n equals t subscript n minus 1 plus 0.1, and there we have it. Okay, so now let's plug this into our calculator, and I'm going to write down the steps, what we need to do. So, so this here is p, this here is y, and this here is t. Okay, so so my p value is 10. My y value is 1. My starting time is 0. Okay, and then so let's write in our equations here. So so for p, we're going to use this equation here. So u parentheses n minus 1 close parentheses plus 0.1 parentheses v parentheses n minus 1. All right. Okay. For my y equation, I've got y parentheses n minus 1 plus 0.1. Okay. And now I write this here, which is negative 5 v parentheses n minus 1 minus 18 u n minus 1 plus 117. And it looks right. And then lastly, omega parentheses n minus 1 plus 0.1. All right, so let's type this into the calculator. Okay. So what do we got here? Okay. So first thing I'm going to type in the pink numbers. Just I like to get that over done with. 10, 1. Okay, and that's already 0. Okay. And the only thing I really need to change is these parts here that I'm highlighting in green. Everything else seems to be the same for every single question. They always seem to have a step of 0.1. This part that I didn't highlight always stays the same. So let's change this here. Okay. Oh, in fact, that line's the same, isn't it? Okay, so I only need to change this line right here. So back to here, delete, 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 delete. Alright, so now I'm going to type in this long green line right here. So negative 5 v parentheses n minus 1 close parentheses minus 18 second 7u parentheses n minus 1 close parentheses plus 117 close parentheses. Okay, hopefully I've typed it in correctly. Okay, starting at 0. Okay, second window gives me this, and we want to start at 0 or 1 or whatever. Okay, so now, second graph to get our table. And we're trying to figure out, find the long-term stable price of the product. So X is the price, right? So if I look here, you can see the price seems to fluctuate. But it seems to be kind of leveling off at 6 something. And if I look at my textbook, keep going down. My textbook says that it levels off at 6.50. So it is stable at $6.50. Okay. And so the long-term stable price. Now, all the other examples I put in the assignment did not stabilize at a particular thing, so there's something special about this problem where it stabilizes. So there you go. All right. So let's look at the other problems. I'm just gonna walk you through it. Okay, so this one here, once again, IB vodcasting. This is their problem. I do want to mention that in this word example, it's very nice, where they talk about displacement. X is displacement. Dy dt, why did I put an X there, is velocity. And the second derivative gives me acceleration. So this is an applied version of using second order differential equations. You might see something with this on an IB test. So you can hit pause if you want to copy this down. And you can hit pause if you want to copy this down. Once again, watch the IB vodcasting link that's on your page, on the top of this page, and he walks you through all of these steps. Hit pause if you want to copy down my work that I did from watching the video. Okay, so just like in all the other examples, we let y equal dx dt, right? And then so that's one of my first equations. And then the second equation is I replace dx squared dt squared with dy dt, and I'm replacing dx dt with y. And then I've got my second differential equation, and there are my coupled differential equations. And then I rewrote these portions of the diff eq in right here, and I put it into my calculator, and these are the values I got when t equals 2. Hit pause if you need to copy this down. Okay, same process. Hit pause. Once again, we set up our diff EQs. Then I wrote down what I needed to do to get started to put this into my calculator. You'll get partial credit from an IB test simply by writing this stuff down, even if you're not able to solve it. Just simply writing the coupled differential equation and writing this is going to help you get points. Okay, here is the answer for this one. Hit pause if you want to check your work. Okay, and same sort of thing. Hit pause. Okay, and there you go.